Good afternoon, everyone. We are going to explain design of a multi-story steel frame building phase 2. Our 5 group members are Isuri, myself, Satira, Andrew, Mohammed, and Boni. Task 1 to 3 going to covered by me and Satira, and task 4 to 6 covered by Andrew and Mohammed, and finally task 7 and 8 by Boni. The main purpose of this project is to use base gas analysis results to develop frames in phase 1 and will design a multi-story design building structure members and will also be ensured that our proposed structure is economical. In reference to our design phase 1, these are our results from space gas analysis illustrating the reactive shear, bending and axial forces from load distribution through the secondary beam. To determine the most suitable secondary beam size that adequately resists the maximum design actions, trial and methods are used for those calculations, and after some trials the most suitable beam size is 360 UB 50.7, and calculations are done as you can see in the slide. After the calculations, since the proposed section 360 UB 50.7 is adequate both in shear and bending with a considerable factor of safety, so it can be confidently used as a design section in secondary beam. The diagrams here equally represent the load distribution reaction on the primary beams from space gas analysis. After some trials, the most suitable beam size is 360 UB 56.7. Calculations are done as you can see in the slide. Since the proposed section is adequate both in shear and bending with a considerable factor of safety, so it can be confidently used as a design section in the primary beam in level 1.
Thank you, Isuri. Then I'm going to talk about the analysis results of space gas ED1 and ED2. As you guys can see, axial load at the ground level, for the ED1 we use 908.662. Then we calculate the shear and the bending moment for the x-axis and y axis. For the ED2, we use the axial load ground level as 1189.61, and we calculate the shear and the bending moment. We got 0 for that one. Task 3. So in the task 3, we are required to design a column located at the F which satisfies the maximum design action from the load combination. So we have to consider axial moment and combination action of the design, and we have to assume the column and cross section are fully restrained. The column size that we use is 310 UC 158. The slenderness ratio ED1 comes with the horizontal wind load. First we calculate along the major axis and the minor axis. For the major axis we got 7650 millimeters. For the minor axis we got 8145 millimeters. After that, we modify the slenderness ratio and calculate the ultimate capacity of the column and clarify that the column size NC is suitable. Then we calculate the design for the combination action and calculate for the nominal member capacity. For that one, we got 304.92 kilonewtons per meter. Finally, we calculate the biaxial bending capacity of the members and substitute to the equation that shown in the slides and got the final answer. Then I'm going to forward to Andrew for the next presentation.
Hi, my name is Andrew, and in this part of the presentation, we will be discussing task 4 and 5 about connections. To begin with, a simple shear connection will be established between the primary and secondary beams through the webs where the secondary beam will be double cooked. The connection at the internal primary beam EFGH will be double side clipped since it is connected to two secondary beams from both sides. As per our design capacity calculations, we proposed the grid 8.8 M16 bolts to be used and the nominated equal angle of 65 times 65 times HEA. For the plate dimension and measurements, the calculated pitch distance between each bolt will be 100 mm while the edge distance will be 32.5 mm. Moving on to moment connections. A moment resisting connection will be put between the primary beams and the columns through an end plate bolted to the column's flange. In this connection, 4 bolts are to be used of the same bolt size grade 8.8 M16s, whereas the nominated weld size would be the E46 fillet weld 8mm SP weld leg size. The nominated flat plate would have the dimensions of 15mm thick, 256mm in width, and 459mm in length.
Thank you, Andrew, for presenting. I would like to talk about the column and connection to footing. As you can see, the axial load is given at 908 kilonewton, and the moment at X given at 71.73 kilonewton meter, and at Y is given at 32.42 kilonewton meter, and shear at X given at 34.66 kilonewton, and shear at Y given at 18.25. These results are obtained from the space gauge analysis. On the left side, you can see the rough diagram shows the connection of balls to the plates as well as top view of the column, and the bolt used is M20. The maximum shear being applied at the connection is 39.17 kilonewton, which is the resultant shear force from the Y and the X direction. There are 4 balls. Each ball would experience 9.79 kilonewton. The tension acting on the ball is 102.6 kilonewton. The connection which is designed can withstand 92.628 kilonewton shear and as well as 162.68 kilonewton in tension. Checking with the adequacy formula for combined shear and tension shown in the slide, the total is 0.408, which is less than 1, so it is adequate. Shear force acting on the weld is 18.56 Newton by millimeter, and axial force is 486.67 Newton by millimeter. Moment is 165.02 Newton by millimeter. These are the forces that are acting on the weld. So the total resultant load acting on the weld is 504.22 Newton by millimeter. But the weld is designed to withstand load of 1430.278 Newton by millimeter, so it is adequate.
So for task 7, which are the drawings for the design project, on the left is the 3D view of the whole structure, which is modeled by using Revit, and on the right is the plan view, where for primary beams we are using 360 UB 56.7, and as for the secondary beam we are using 360 UB 50.7. And this is the side view of the design project. This is the drawing for the connection for secondary beam to primary beam. The bolts used are M16 grade 8.8. This is the connection for the primary beam to column, where the steel plate size is by 256 millimeters by 459 millimeters. Its thickness at 15 millimeters, and the bolt used is M16 grade 8.8. These are the drawings for the connection of column to footing, where the bolts used are M20 grade 8.8, and the steel plate size is 451 millimeters by 517.2 millimeters. For task 8 is to estimate the total material cost, where we mainly use 360 UB 56.7 for the primary beams, 360 UB 50.7 for the secondary beams, and for the column we use 310 UC 158. For the rate per unit of 360 UB 56.7 is 709 ringgit. For the 360 UB 50.7 is 638 ringgit and 50 cents, and for the 310 UC 158 is 2,229 ringgit and 80 cents per unit. The total would be amounting to 923,348 ringgit and 97 cents. And that is all for our group, and thank you.